Okay, today we're going to learn how to construct scatterplots. We're going to go over some basic rules about graphing and setting up the axes together, and then you'll have some practice problems to do on your own. This video lesson will not go over those practice questions. You will have to bring your sheet to me so I can check your work, and then I'll record your grade accordingly. The first sheet, though, is going to be covered in this video lesson, and that is the sheet that is also titled Constructing Scatterplots, but I believe it says Student Handout at the top instead of the other sheet that you're going to do independently says Homework 2. So I'll give you both papers. Obviously fill out the one that goes with this video lesson, and the other one is for you to complete independently, but I'll help you get it started. So in your notebook, if you didn't fill this out yesterday, today's date is the 11th, and you're going to tape your information into your notebook pages 93 and 94. Okay, so the first thing about constructing scatterplots is you're going to have two variables. In this case, Jared's basketball team stood at various distances from the basketball goal and counted the number of baskets they were able to make in 30 seconds. The distance each person stood from the goal, which is our top information here, okay, then that we're going to use as our x variable, so label that x. The other information that was recorded is the number of baskets made in the table, and that's going to be our y coordinate. So first thing you always want to do when you're given information is make sure you label who's x and who's y. The next thing you're going to do when you have your graph in front of you is you're going to figure out what the best way to set it up is. In our case, again, x and y get to be labeled. And what we decided to do with this one, in order to fit all the data in for our x-axis, you have to make sure you can plot points that are all the way out to 28 feet. So I think the best way to set this up is to go every other box. So put little tick marks down there. Oh, and make sure that you label your variables as well. Not just x and y, but really need to know what we're talking about. Down here, we're talking about the distance they are from the basketball they called a goal. And then the y variable is the number of baskets that they were able to make in the 30 seconds. So now we're going to label those little tick marks that we already made. And again, we need to make sure we go all the way out. This should say 28 if we're going by 4s. 4, 8, 12. You want to consistently make sure you're increasing all the way up to 28, and that will allow us to plot every single point for the people that we have information from up above. For your y-axis, if we decide to go every other box and we go by 4s, it's going to go too high because as you can see, the baskets made, it looks like 14 is your highest value. So on the y-axis, we can actually change our scale a little bit and we can go by 2s. This bottom is still 0, but we'll skip 2 boxes and we'll have 2, 4, 6, 8, 10, 12, and then 14. So we will have room to plot our values, and that's really the best thing you want to do when you're constructing a scatter plot is once you figure out which variable goes on which axis, you really need to kind of plan out what scale you're going to use. And it's okay to use a different scale like we just did. Consistently you can go by 4s, consistently you can go by 2s as long as they're labeled. You're ready to plot your points. Your points are as simple as looking at each person. Jared is going to be 14 feet away from the goal, so we need to make sure we figure out where 14 is going to be. And then we just need to make sure we plot the number of baskets he specifically made in the chart, 4 baskets. Terrell is out to 25, so again, you're going to have to estimate where 25 is. And you're going to want to plot your point up at 6. And then Anthony is at 27, but he made 7 baskets. Mark is at 15, so it's a little bit over here, and he's way up here at 11, so he's able to make a lot more baskets than everybody else so far. 26 feet away, we have 6 baskets. Kevin, we have 16 feet away and 13. Wade, we have 15 feet away with 12. Kyle, we have 26 feet away with 8 baskets. We have quite a few data points together over here. We'll talk about that in a little bit. Let's see, we're up to Chris, who is 16, 14. I think we had another one earlier, 16, 13, so be careful that you get those 2 on there. And then Tim at 28 and 5. So unlike the scatter plots that we looked at the other day, we tend to have a grouping of points here and here where the people who made the baskets really made similar numbers of baskets at this distance and at this distance. You'll notice this one point over here, I believe this was Jared. He had kind of a unique value that he was able to get 4 baskets at 14 feet away from the basket. So first, we're going to talk about the type of association we see in the scatter plot. Remember, an association kind of gives you an idea of what's going on with the values. The farther they were from the goal, this group of people really didn't have that many baskets compared to the people up here that were closer. So I would like to say we have a negative association, but there's a little issue with this point over here. Typically, a negative association has all your points kind of lining up in a nice way. So I guess we could say this is a negative association, but it's a really weak association because they are not really all together kind of going in the same direction. So if we said negative, the points seem to have a gap. There's also one point that doesn't fit the pattern. So this brings us to some of the vocabulary that we're going to talk about today. Sometimes when you have data and you construct your scatter plot, we do not have a perfect pattern. Okay, but first let's just go through these true-false questions. Using the scatter plot as the distance from the goal increases, the number of baskets made decreases, and that's the general trend. The farther we are away, they didn't make as many, so that one should be true. Part B, as the distance from the goal decreases, in other words, we get closer, the number of baskets made increases. And that's kind of true also because these people were able to get a lot more baskets than these people. The only one that's different is that one point. So we can still say it's true. It's general of an information. For part C, as the distance of the goal decreases, the number of baskets made decreases. And this is false because as you get closer, we did have one person who made less baskets, but most people made more. So we're going to say false. Okay, so that one point that we talked about really doesn't fit the general trend of the other points. That's called an outlier. It's a point that does not fit the overall pattern or trend of the scatter plot, and that's what they're called, an outlier. The outlier in the scatter plot above, remember, was Jared. He had 14 feet away from the goal, and he only made 4 baskets. So maybe he just wasn't feeling well that day. The number of baskets he made was much lower than the rest of his teammates who stood at a similar distance from the goal. Another vocab word that we need to learn about today is called clustering. Clustering occurs in a scatter plot when there are distinct or separate groups of points. Remember we talked about all these people that stood far away from the basket really had similar results, and so did the people that were standing closer. They all had similar results. So we call those clusters. In the plot above, it seems that a group of players who stood closer, this group right here, made similar or had similar results, and then there's another cluster right here. So outliers and clusters are the vocab words that we're working on today, and we'll get you some practice in just a minute. In this graph, they have set up the scale for us, and if you notice, the first box over is going to be 10, in other words, 10,000 people for our population, and then we skip boxes and they labeled 30, and then 50 and 70. So be really careful when you go to plot your points. The first point of 76,000, you really have to gauge where it might be in between. Here's 70, here is 90, so of course 80 is in the middle and 76 is pretty close to that. And then your y-axis, which is representing the number of elementary schools, your y-axis is at 19. So that's this point right here kind of floating in the middle for that first person. 60,000 is easy to find on the x-axis, but then again you got to kind of estimate where 17 would be because this scale went up by 2s. This scale is going by 10s, and it's marked in thousands, and that's because they didn't want to have to put all those little zeros on the bottom. So go ahead and get these points plotted. You should end up with a scatter plot that looks very similar to this. And then we'll go over the questions that follow. The questions talk about describing any association between the variables, and I think you could definitely see a positive association. As the population increases, they need more elementary schools, so the elementary schools increases as well. Now they're asking us our new vocab word, outliers. Do you see any outliers in the data? And again, an outlier is a point that really doesn't group together with the others. So if this is your main group right here, do you notice the outlier? And it looks like if we try to find the data for that one point, this point here, this 20,000 for population, they had a lot of elementary schools compared to the other people in their same population area. So that would definitely be considered an outlier. That point is much higher than the pattern of data. And then the last one, is there any clustering? We don't really have clustering because at least these are spread out and they kind of form a straight line, which is more like a trend line that we're going to talk about. So it's not really any distinct clustering like there was on the other questions. Now, your last example, Tuesday after school, Charlie asked 9 different students how much money they had in their lunch account, as well as how many homework assignments they had that evening. Use the data he collected to make a scatter plot. So your plot is going to have your amount in your lunch account. It's going to have your homework assignments plotted also. So you've got your X and you've got your Y. And you want to take a minute to make sure you can correctly plot those points on there and get practice estimating where about 824 is and 0 homework, 2905 and 2 homeworks. Okay, make sure all the points get on there. He said he had 9 students, so when you get done, there should be 9 points. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's another way you can check to make sure you have all your data plotted. And then you want to look at your scatter plot. Okay, do you see a certain association? Do you see a clustering of points? Do you see them lined up a certain way? What you should conclude from this graph, since the points are scattered all over the place, is that there is no association. The amount of money you have in your lunch account is not going to have any effect on the homework assignments that you have. Part B says, are there any outliers? Well, again, because you don't have any kind of association and the points are all scattered all over the place, that doesn't create an outlier. An outlier, remember, looks like this, where most of your points form a trend, and then you have one point that's totally out there by itself. So no outliers in the scatter plot. And the last question, is there clustering? Okay, remember what clustering looks like? Clustering is going to be a bunch of points that are together in one area or another of the graph, and our points are scattered all over the place. So that means there is no clustering for this particular graph. There's no pattern. So there can't be clustering and there can't be any outliers. All right, now that you have your note sheet correctly filled in and you've been able to practice your new vocabulary, what you need to do is you need to practice getting this information from a chart into a scatter plot. So you'll notice this one is set up for you. You've got your length of cruise, your X value already set up as the X-axis, and the scale is done for you. You've got your cost, okay, for each cruise listed as your Y value. So you're going to take a few minutes, you're going to plot those points so you can answer the questions about the scatter plot. And then for the back of the homework page, you get to set up your own graph. So remember, this can be your X, your number of people. This can be your time. So make sure when you set up your graph, you are setting it up properly. The number of people will go down here. And then look carefully at your data to make sure that once you set up your scale, you're going to be able to fit all the people in there when you go to plot your points. And then please use a different scale. Okay, your time does have to go on the y-axis. And we need to make sure, again, when you plot your values, you can get all the way up there. It looks like 400 is the highest time. So you're really going to have to make sure you use a different scale to make sure that you can reach a point to plot this value of 400 minutes for that one person. Once you have your scatter plot set, you'll be able to answer the questions about it. And then when you're finished, you'll need to show me that you completed this assignment, and then we'll have you tape it into your book so that it will be complete. See me if you have any questions.